Okay, so welcome everyone to our talk. Wasm, Envoy, and Hyperlight walk into a pod. No vulnerabilities allowed. Today we'll talk about a couple of things, starting off with cloud security. That's just sort of setting the tone and getting us all on the same page about a couple of concepts that we'll talk about. Then we'll do a series of 101s covering a couple of technologies like Hyperlight, WebAssembly, Wasm, and Hyperlight Wasm. Then we'll go over a use case of customer-provided Envoy plugins, discuss a couple of things there, and then finish off with our summary and plans. But before we begin, I just wanted to introduce ourselves. I am Danilo, or Dan. I'm a software engineer at Microsoft. I'm a core maintainer of the Hyperlight project that I just talked about. And I'm the author of Manning's server-side Wasm book, also a champion of 7 Wasm proposals, and a big Star Trek and Smash Bros. Fan.
Hey. My name is Mikhail. You can call me Mike. If it's easier, I'm also a software engineer in Microsoft, mostly working on service mesh, things like Istio and Envoy. SRE in previous life, and I guess a fun fact, I spent my free time educating my little puppy to not bite my hands off. So that's it.
Cool. All right, so now let's get into it. Or rather, before we get into sort of the meat and potatoes of this talk, this is sort of that cloud security section on our agenda, covering some background items. And in particular, I want to talk about isolation. So when you think of running apps, there's 3 sort of methods of high-level isolation that you can think of. The very first one is the absence of it. You can think here you just have a couple of apps running on your own on one OS. These can be sort of process isolated, so sure they have some sort of isolation, but nothing specifically isolating them that's dedicated to that. Next up, we have weak isolation. So right here, the apps could be leveraging kernel features to have that isolation that could be, say, C groups, namespaces, sort of how containers run. And then we have strong isolation. These apps now are leveraging something like a hypervisor or some other similar technology to be fully isolated from one another and potentially even have their own OS. But let's dive a little bit deeper into that weak versus strong isolation with a containers versus hypervisors face-off. With containers, between 2022 and 2024, we had 7 reported container breakout vulnerabilities. These are vulnerabilities stemming from the use of those kernel features that give them the weak isolation. And what this implies is that then containers are not really suitable for multi-tenant architecture, so where customers are sharing infrastructure. Hypervisors, on the other hand, like KVM or MSHV, provide a different API to create isolated memory, configure a virtual machine state, create a vCPU, and run a vCPU, and they do that through harder virtualization extensions like Intel VTX or AMD V. So they're not using those same kernel features that create those vulnerabilities. And that's where Hyperlight comes in. So Hyperlight is a library that allows you to leverage underlying hypervisor technologies like KVM, MSHV, or WHP, the Windows hypervisors, to create micro virtual machines to execute some untrusted or potentially malicious code safely. And what's more, Hyperlight was recently donated to the Cloud Native Foundation. And we're just accepted as a sandboxing project. Okay, let's take a look at a quick Hyperlight Hello World application. What does it entail to use Hyperlight? First off, the very first thing you have to do is create a uninitialized sandbox. What you do here is you have some sort of potentially untrusted code that you load onto the sandbox. This can be a native ELF binary, it can be JavaScript, it can be WebAssembly. We'll show examples in this presentation running WebAssembly, but we also have blog posts, shoutouts Ludwig, for running JavaScript that you can Google and find. Probably just like Hyperlight JavaScript will find you that blog post. Once you have that guest loaded, what you can do next is register host functions. This is important because by default, Hyperlight guests don't have an OS. So the APIs they can access are available via host functions because they don't have access to syscalls and an OS that an OS would usually provide. So once you have the guest loaded and you have host functions registered, you can evolve your uninitialized sandbox into a multi-use sandbox. This is essentially just a initialized sandbox that you can then use to call guest functions. In this example, we're calling a guest function called print output. This function here, all it does is it goes into the guest, and then it exits the guest to call a host function that prints output on the host's standard output, and then will return to the guest. But say that you're running some sort of application that you want to allow user plugins or some sort of architecture like that. You could have your plugin API be that the users define a run function, and then this call guest function by name would call that run function to execute that code within that hypervisor partition safely. Okay, now let's talk about a different isolation technique called WebAssembly. We talked about a bit about it previously as a binary format, as one of the things that we can run in Hyperlight. But it's a little bit different than just your ELF binaries, because for once it's architecture independent. So as you can see, this figure to my side, WebAssembly it's not specific to say x86 or ARM, and instead it abstracts over those architectures, sort of this harder abstraction layer or HAL. And it's also safe by design. It's designed to be executed within the sandbox environment where you opt into specific capabilities. So in this example, we have capability 1 and 2. Those are explicitly granted to an application, and then the application can make use of those, but say some sort of capability 3 cannot be used. And those will correlate to syscalls. Now, comparing the two, they have a lot of similarities, right? Wasm and Hyperlight. On my right, we have the native OS, Wasm runtime sandbox as the isolation method. On my left, you have the Hyperlight with the native OS, Hyperlight as the sandboxing method. And then you have that same API to opt into capabilities. But the difference I want to highlight here really is just that difference in isolation method. On Wasm, sort of the new kid on the block, right? You have the Wasm technology, while in Hyperlight we're leveraging, hypervisor technologies that have been used for a while and are oftentimes a requirement for running third-party code in public clouds. But what if we combine the two? That's where Hyperlight Wasm comes in. Hyperlight Wasm was just announced a couple of days back on March 26th with this blog post if you want to read more about it. But what it promises to do is bring this defense in depth, where we have not just the Wasm sandbox, not just the hypervisor sandbox, but we have the hypervisor sandbox with the Wasm sandboxing running then your Wasm component. Now for a demo. Okay, so in here, hopefully this is big enough. What I'm doing, hopefully I can move my mouse, there we go. We'll go into more detail about this API a little bit later with Mikhail's section, but in this example, we're creating that uninitialized sandbox with some specific configuration, sort of like heap size and so forth. We're registering host functions, just like we saw in that previous Hello World example, except in here, instead of registering a specific host function, we're leveraging something that WebAssembly has, which is WIT, WebAssembly interface types, to create those bindings specifically. So in here, you see the WIT. It has the definitions for start bind, finish bind, subscribe, and these would be host functions that a guest would be able to call that can be registered like so. For Hyperlight Wasm, you have an added step other than just initializing your sandbox, which is loading the runtime. That is what's capable of running a Wasm component, and then you load a module. You notice that this says echo.bin instead of echo.wasm, and that's just because we ahead of time compiled that WebAssembly component. And then you're ready to run. And now you may ask, what are we running? And this is it. So that's that echo.wasm application. This is an application that was compiled to Wasm. What we do is you bind to a socket. We start receiving packets on a loop, so we're just hanging forever. And then when we receive those packets, we just echo, and hence the name of the application, then back to the sender. So now, demo gods be with me. If I cargo run, okay, perfectly this hangs. And now I can go in here, run nc, and now whatever I send it, send a hello, it should send it back out. Cool, so I get a hello, I can say world, and there we go, we get a hello world back. So I guess to summarize here, what we're doing is we created that uninitialized sandbox on the host side, we rendered on the host, and then in C, it's calling all the way into the guest, so doing a VM, going into the VM, executing the guest code. The guest code can call host functions, do VM exits, and then resume guest execution, going through that barrier, you know, the Wasm sandbox, the Hyperlight sandbox inside of the hypervisor to execute this code and output that back out. Okay. And with that, I will pass it off to Mikhail to talk about a different use case.
Thank you, Dan. And that's where Envoy gets into a pod. Let's take that echo example that Dan just showed and put it inside Envoy. What is Envoy? So before Envoy, a little bit of background. This work came out of a 2 weeks hackathon project, and when I started, I didn't know anything about Hyperlight and knew very little about Envoy, so I hope it will encourage you to try on your own. It's not super hard. But what is Envoy? To put it simply, it's a configurable proxy. It's configured through a set of plugins, both built-in, and you create your own plugins in Go, Lua, anything that compiles into WebAssembly using a thing called proxy Wasm. So those plugins expose callbacks, and Envoy calls those callbacks during certain events, like new connection established, or data arrives on these connections. Envoy calls into a plugin tells Envoy what to do. So plugins basically decide everything that Envoy does. And for this example, I would like you to keep in head a hypothetical, so not hypothetical anymore, example, use case where you run a service built on Envoy, right? And you want to expose this customization feature to customers. So customers create their own plugins, give it to you, and you run them on their behalf. Since it's not your code, you probably don't want to like fully trust them and want to consider some protection mechanisms, like some defense in depth. And that's where Hyperlight wasn't come into picture. So what I want to demonstrate is an Envoy network filter that instead of doing logic itself, will call into Hyperlight Wasm, into WebAssembly model running inside it, that will actually do all the processing and return back to Envoy. A bit of background here. What is Envoy network filter? It's one of a simpler filters. It basically tells Envoy how to handle a TCP connection, and it has a couple of callbacks. One is on new connection, self-explanatory, and on new data. Again, self-explanatory. Just wanted to get out of the way. Now, reiterating a little bit what Dan already showed, what do we need to do? Well, we need to create a configure Hyperlight Wasm sandbox. We need to provide pointer to a WebAssembly model. We need to define an interface between host, which in our case Envoy, and the guest, which is Hyperlight Wasm with a WebAssembly model inside it. And yeah, that's it. For the sake of example, I will only show the interface required for the echo functionality, but it could be like arbitrarily complicated if you want. Well, let's dig a little bit deeper into setting up the sandbox. You saw very similar code already. So what does it take to set up a sandbox? Well, that's pretty much it, right? There's not much to it. You configure the sandbox, what kind of parameters you might consider configuring in a real life example. Well, if you're running somewhat untrusted code, right, you don't only worry about the code escaping the sandbox. You also might want to put some constraints so that it doesn't use all the CPU available on your machine or all the memory available on your machine, right? Well, that's pretty much what you set up here. You set up limits on the WebAssembly runtime inside Hyperlight. On the Hyperlight itself, you set up limit on how long does you allow it to run before you start worrying and interrupt it. And the last part is just give it a model to run. That's all it takes. I skipped a bit here. You will see it a little bit later. For completeness, this is the Echo WebAssembly model. It's even simpler than Dan showed earlier. It basically exposes one function on data. That's what Envoy will call when data arrives on the connection. And this function doesn't do anything except like calling back into the host to say that, well, send it back. Like I don't want to deal with that. But obviously, the model may implement a more complicated functionalities just for the sake of the example. Now, let's take a look at the interface between the host and the guest. So guest call, right? That's when Envoy will call into the Hyperlight. Well, it's not significantly more complicated than just calling a function, right? The caveat here is you call it by name, like in this case it's on data. You have to encode parameters of this function in a certain way, and you declare the type of the returned value. The reason you call it by name is because when Hyperlight guest starts inside Hyperlight, it normally registers all the functions that you should be able to call, and that's how Hyperlight knows the available names. When it comes to parameters, well, obviously there is some like serialization, deserialization going on when you cross the boundary from between the host and the guest, so you have to encode those parameters so that Hyperlight can understand them. Hyperlight has like relatively simple but reasonably complete type system that contains all like integers, floating point numbers, like vector of bytes, strings, whatever really you want. In this particular case, I'm passing a vector of bytes and the size of that vector of bytes. It's a little bit of quirk just for people who read the slides carefully. Vector of bytes already contains its own size, so you shouldn't really need to pass it, but it will go away in the future versions of Hyperlight Wasm, so you don't need to worry about that. Now, host calls. With WebAssembly and Hyperlight, they do not really provide you with facilities to interact with external world. So if you want to talk over like networking connection, that's not like a part of WebAssembly. All of that functionality has to be provided by the host. In our case, the host is Envoy, and that's like just how you send data back. It's not super interesting. Let's just assume that we have this functionality implemented in the guest or in the host. How do you expose it then to Hyperlight? Well, that Dan already showed you just register this function with a name and call back, and that was the part that I skipped in the initialization. And that's basically it. At this point, your sandbox, Hyperlight sandbox is created and you can use it. One thing, sort of a practical aspect, right? You can circumvent a little bit the Hyperlight type system and use vec bytes for everything and use things like protocol buffers, flat buffers, whatever you prefer tool for serialization, deserialization of data, and just pass it in. And you will get whatever interface you want, and you wouldn't even need to think about like the Hyperlight somewhere there in between, right? So that kind of simplifies your work a little bit. Now let's take a look at the demo. The magic hand gesture. Yes, here we are. So I will show you now Envoy with a Hyperlight plugin that doesn't do anything. It just like loads a WebAssembly model that implements the logic. I will just start Envoy. It started rather quickly. Let me show you the config. It's relatively simple. The relevant part is the Hyperlight at the very end that just basically tells Envoy, please run the Hyperlight plugin. And that's it, right? The only configuration parameter in this case is just pass to WebAssembly model, and that's it. And now, when we have Envoy running, I can connect to it. Yep, I can. And it speaks to me, which is good. So that's basically it. We can see that there were some logs here that show that plugin actually got called, but that's basically it, right? We now had a case where WebAssembly model running inside of Hyperlight did something like when Envoy asked it. And coming back. Now, some integration challenges. Like, hopefully, I will make you believe that it was super easy to integrate Hyperlight into Envoy. I ran through that pretty quickly. What didn't work well, that well at least? One of the more obvious things is that Envoy is mostly C++ code base, for better or worse. Hyperlight is like pure Rust. So you have to deal with a few things there, like you have to provide some boilerplate to be able to call Rust code from C++, and vice versa, like C++ code from Rust, because host guest calls go in both directions. It's not insignificant amount of boilerplate, but it's also not particularly complicated. So that's not a big problem. One thing that kind of caught me by surprise, but shouldn't have, is Hyperlight is multi-threaded. So when you call into Hyperlight, when you make a guest call, the thread that called into Hyperlight will get blocked, and all the host calls will come from another thread. That was particularly difficult for Envoy to handle because Envoy, as many other networking applications, is like sort of asynchronous, callback-based. Most of the processing happens in the same thread. And because of that, they actually don't need to lock much. So if you start calling into Envoy, like accessing Envoy data structures from another thread, like it's not prepared to do that. And sometimes it just doesn't work because they heavily rely on thread local memory, thread local storage. So you wouldn't be able to access those structures anyway. You just get nulls or whatever. So I had to like add some boilerplate to handle that, to return all those callbacks to the Envoy working thread so that it can access actual like Envoy data structures. So that's one thing to keep in mind. And the last one is not really an integration challenge. You might easily miss that, but it's important to understand that Hyperlight Wasm, at the moment at least, does not preserve the state between guest calls. So you call into guest, your guest worked something, like initialize some pieces of memory, some structures and whatnot, and then guest call finished, you call again, all that state will be lost. That limits somewhat functionality of what you currently can put in Hyperlight Wasm. And as I said, you can miss it, so saying it now. Now, the interesting part. We created our like defense in depth. Like, what did it cost us, right? So let's take a look at some relatively simplistic benchmark that I did. So the idea of the benchmark, like I run this echo functionality, so very minimal logic. I send a request, fixed size, random data to Envoy, get a response back, measure how long it took. Right, and repeat it multiple times to get an idea of what the average value, what the variability is. And I also change the amount of data I send, like just to see if it affects something. What do I compare here? I compare here Hyperlight, Hyperlight Wasm. I also implemented a native Hyperlight guest without Wasm that just implements the echo functionality, but there is no WebAssembly runtime or anything of the sort involved. And I'm also comparing it to proxy Wasm implementation of not exactly the same, but equivalent. It also implements a echo functionality, but like proxy Wasm is a different thing, so it's not exactly apples to apples comparison. So I think like people who look at the slides kind of picked up on the, and Ralph also forced me to say that performance of Hyperlight sucks. Done. Yep, it is where we stand now, but it's not where we want to be, and there are definitely some low-hanging fruits there. I did some initial profiling. I was able to actually optimize Hyperlight native. When I mentioned earlier that Hyperlight Wasm kind of loses the state between the calls, what I actually meant is that it goes and actively wipes it out. And that's not for free. And Hyperlight native actually allows you to like skip this bit, and it saves like 15% of like runtime. Easily. There are some other low-hanging fruits that can be optimized as well. And I'm pretty sure that my integration wasn't the best ever. So there might be some overhead there as well. An interesting part is, like, as you can see, like on the left, we like sent 128 bytes, on the right 4 kilobytes. So it's like 30x-ish difference. And if you like squint, you can see that there is like a trend there. The more bytes you send, the more time it takes. But compared to the rest of the overhead, it's kind of lost there. So yeah, that's where we are at now. So where are we going in the future? Before that, let's summarize quickly. We achieved defense and depth. Cool, well done. It was simple. Cool, well done. Performance could be much better, put it mildly. So yeah, that's the summary. Where do we go from here? Some obvious things to get it out of the way. There is an ongoing work to provide some kind of C API to make it easier to integrate into non-Rust code bases. Well, that's out of the way. We want to integrate Hyperlight Wasm as another proxy Wasm engine. Proxy Wasm, to remind, is an Envoy native way to run WebAssembly plugins. It supports multiple engines already, like V8, Wasm time, whatever. Hyperlight could be one of those as well. Performance will become a focus area. As I mentioned, there are a lot of low-hanging fruits. There are some problems as well. Like, for example, it's not currently super easy to profile overhead happening inside the guest because like profiler just doesn't see it, right? We need some tooling to make it visible, like, or to make Hyperlight transparent. But like, it's going to be also pretty important to optimize performance even beyond the low-hanging fruits, because the idea of, like, and the use case for Hyperlight is to put relatively small computation inside a sandbox, and the smaller computation is the more significant relative to this computation the overhead of the sandbox becomes. One cool thing to mention, and then said earlier, like WebAssembly is like architecture independent. Yes, Hyperlight doesn't support ARM yet. There was some work done to make ARM work, but we are not there yet. So something to tune in for future updates. Hopefully, it will be great. And on this note, I will probably pass the mic to Dan to tell us about his awesome book.
Yeah, this is just a bit of a shameless plug before we pass it off to questions. But like I mentioned in the beginning, I am authoring this book at Server-Side WebAssembly with Manning. It's currently in early preview, but if you want to check it out, you can use this QR code to do so. Oh, and also for questions, I have some free books to give out, or codes to get the free book. So I guess maybe 5 first questions, you get a free book. OK, and I guess with that, we pass it off to questions.
Mikhail, I was going to ask you whether one of the things that very much interested me was the lack of state retention. Mm-hmm. And when you mentioned that, so I was going to ask you about your experience with Envoy. Are there, what kind of situations occur where state retention is actually something that in Envoy network filters is used now?
Envoy is like very much stateful in this regard, but like to conceptualize where do we need it, right? Imagine this, like if I return a little bit back to the interface of this network filter. Sorry. Yeah, here. So on new connection is called once, but on data is called like multiple times. The data may arrive to you in arbitrary chunks, right? What you might want to do is, like, for example, if you want to build like HTTP interface out of it, you take and incrementally parse it, and for that you need to preserve the previous state. There's like a bunch of other examples, like maintaining counters of different type, or like For example, if you process an HTTP request, you do something when you get the headers, you calculate something throughout the body, and then like append some trailer in the end, right? This would be an example where you kind of have to preserve the state between like various calls. To be honest, like, you don't have to do it this way, right? You in principle can imagine a different architecture where you kind of maintain the state throughout somewhere else, but it will be relatively complicated and will complicate the plugin architecture, right? If you ask Envoy to like maintain everything on your behalf, right? That will just make the plugins less powerful.
Any other questions? I actually have one. So you talked about defense in depth as the reason for putting Wasm inside of Hyperlight. Can you expand a little bit on that?
Yeah, sure. So you want to know, I guess, the security aspect of it, or?
Yep.
Okay. So, well, one thing, you have, hypervisor technologies that have been used for decades, and we accept the security of them with KVM, MSHV, WHP. Then on the other side, you have Wasm, which has a bunch of other benefits that we might want to use, like it's language agnostic. I guess maybe the architecture-independent bit gets a little bit lost if you're running it with Hyperlight. Doesn't support ARM, like Mikhail mentioned. But there's a bunch of benefits with language agnostic and so forth that you might want to leverage with Hyperlight and still be able to run with some sort of third-party cloud, or that perhaps wouldn't run just the WebAssembly runtime by itself. So putting that within Hyperlight enables it to run in that scenario, and you can still use the cool new modern bits that are coming out today.
So it enables a lot of interesting use cases where you use the Wasm interface and you get the value of the hypervisor.
Yeah, that's right. Even the example that we saw with the WIT, right, and being able to use that WIT interface to register host functions. Using core Hyperlight, that will look very different with just registering a bunch of host functions that are specific. While on the WebAssembly side, there's a bunch of those interfaces that are standardized, and that can then have also standardized host implementations that you could then just get sort of out of the box SDK free.
Thank you.
Just a bit of like Envoy context in this. When proxy Wasm was introduced, one of the things that they how they pitched it, why it's useful, why do we want to introduce it, was that Envoy internal APIs are not going to be stable, but proxy Wasm APIs are going to be stable. And that's why, for example, proxy Wasm is actually not just for running WebAssembly inside of Envoy. You can actually use proxy Wasm to run native plugins inside of Envoy because it provides a stable interface. So that's kind of WebAssembly kind of indirectly created a stable interface for extending Envoy that wasn't there before.
Great. Thank you, guys.